Hey everybody, MS Farzan here, and welcome back to this video series on learning C# and Unity for digital tabletop game development. We've been spending a lot of time logging things to the console, and I hope that's been helpful in exposing you to some of the concepts that we're going to be working with moving forward. But it's time to return to the Unity editor and learn the other half of developing in Unity, which is working with the editor to actually display stuff on screen. So we won't actually be working in scripts all of the time. In some programming languages and game engines, you're actually just using your programming to make everything happen and to render stuff on the screen. But Unity has the editor that handles a lot of that stuff for us as well. So I'm going to jump back into the editor, and we haven't really done anything here other than attach a script to an empty game object. So now it's time for us to figure out what to do with that game object and how to render stuff on the screen. The first thing I'm going to do is, because I'm going to save this game object and I want to use it for everything that we're going to do in this part of the tutorial, I'm going to change its name to token. Like a token that we put on a game board, or you can think of this as like a card, or it might be a representation of your player that you'll have a sprite attached to that looks like one of your players on your game board. We're just going to call it token right now. And we're going to create a new empty game object, either by right-clicking here and saying create empty, or going up to the game object menu and creating empty. And that's going to create another empty game object underneath my sample scene in the hierarchy. And I'm going to rename this background. And what I want this to be is an item that is going to be rendered at the back of the screen behind everything. That is, let's just say it's we'll just make a plain old black color here. What I can do here is go to make sure that I've clicked on it in my my hierarchy here, and then I can add a component here, and I can search for image and just say I want it to be an image. And something that I could have done instead of this, for example, is gone up to game object and instead say I want to create a 2D a user interface object, and I want to create an image. And when I do that, I have pretty much the same result. And I want you to see that I can do things differently, either by creating it here as an empty game object and attaching an image, or I can go up to this game object menu and do the same thing, which is one of the quirks of Unity, in that there are multiple ways to do similar things, and sometimes you can do the same things through scripts as well. So it can be very overwhelming having these multiple different options of how to get there. But when you're searching on the internet for ways to do things, or you're trying to do things the way that I'm doing them, sometimes those might match up or they might not match up, and you might be confused. So just keep in mind that there are multiple ways of doing things, and sometimes you'll get exactly the same results and sometimes you won't. For example, if you create an empty game object like we did, and we call it background as we have, it creates that, but it hasn't done one thing, which is creating a canvas, as we see here. A canvas is a way of providing a blank slate for things that we might want to do when we're creating our user interface for our game. And in a lot of games, like 2D and 3D games, you might use the canvas for a particular purpose, like you want to have your user interface be represented on the canvas, but everything else will be on a different layer, so to speak. Like you're creating a platformer and you want to have your heads-up display, like your health and your enemy health and other, your score, some things you might want to have that on your canvas, whereas your player character and other things like obstacles and things that you can platform on might be not on the canvas. Well, for most of the things that we're going to do for our types of games, they're actually going to be nested within the canvas, meaning the canvas is going to be the parent, and everything that we want underneath it, like this image here, they're going to be nested underneath the canvas as children of the canvas, which is going to be the parent. That's going to be useful for us in many different ways in how we manipulate them. And so what I'm going to do is I'm going to actually use this this canvas for everything that I'm going to do. And when I select it, I can see in the inspector that it right now it has a few different components to it than what I've seen previously. It has the canvas itself, which is set as a screen space overlay. That just means that it is overlaid over everything else in the scene. It has a canvas scaler, which right now has a constant pixel size. We're not going to work with that right now, but we will later. And it also has a raycaster, which we won't be using very much at all. What I want you to get comfortable with is right now it has this image that we've created underneath it, which is pretty much identical to this background image. It's only that the background image is not parented to the canvas. So I'm going to drag the background to the right on top of the canvas, and that's going to parent the background to the canvas just like this. And now we can see the background is just a square image that has this white coloring on it, nothing special. And we'll also see that if I look at over, now that I'm looking at this background in the hierarchy, in the inspector, I see that the color, it says under image, it says the source image, there's no sprite attached to it. We will work with that in a later video. It just has a basic color, which is white. And if I click on it, I can bring up this little color palette, and I'll drag this so that it's black. It doesn't have a material or anything like that. I don't need to really worry about that. If I'm using a mouse right now, and if I hold down the right mouse button, I can move around here using this hand tool, which you could also select up here in the upper left-hand corner. And I can zoom out using the mouse scroller. Just to see where everything is. If I look, I have this other white thing here. That's this image. And if you're wondering, well, why is it right here? You can look at the position X and position Y. It's at -270 and -190. If I click back on my background, either here in the hierarchy or here on my scene view, and if you're not able to mess with stuff here, that just means you're in the game window and not in the scene window. I can click on this this guy right here, or girl or person, and move it around, and you can see on the right hand side of the screen the position X and position Y move with that. So I can move it along with this, or I can just say I want it to be at the origin, which is at 0, 0. And the position X, Z right now is at a weird position. I'll just move that to 0 as well. And now it's at the origin of my scene, right in the middle. So, well, what if I want this to be, not just in the middle of the screen? I want it to cover the screen. Well, I can just, drag it up to the corner here, and it'll snap to the grid. If it's not snapping to the grid, you can go over to Edit and Snap Settings, and change these values as you like to change the snap settings so it'll snap to the grid. And I can just drag all the way down here to the edge here to make sure that it covers the entire area of my canvas. The other thing that I can do is if I look at my canvas, I see that its width and height are matching 1920 by 1080, which is a pretty normal resolution for screens. That's often driven by this game window, which is a little bit confusing, I know. But if you want to get like 1920 by 1080 or some other value, you can just go over to your game window and click on this this resolution and just add a resolution here by hitting the plus button. And you can, for example, I'm using 1920 by 1080, and that's going to drive the canvas value. And then if I am here in this background part of the inspector part of my background, if I wanted, if it started out being as 10 by 10 and I said that, well, that's too small, instead of dragging the corners of it to fill the space of the canvas, I could instead just say 1920 by 1080, 1080, and that will just fill the canvas like that. So now I have a nice background, and when I hit play and go over to my game tab, I see that now I have a background for the canvas. Great. Okay, but I don't see the image, and I'd love to know why I don't see the image. That you remember I had that white image? That's just because if you look at your hierarchy, the position of things on screen is going to depend how they're parented to the canvas. So right now my image is at the top of this hierarchy tree, and things on the screen are going to be rendered closer to your eyeballs the lower they are on the hierarchy. So right now, this is higher on the hierarchy under the canvas, this image. If I bring it down below the background, I don't want to parent it to the background, I just want to bring it below the background. Now I see it and it's closer to my eyeballs. And when I click play, I'll see it on the screen, just like that. I'm going to delete the image. I don't really need this, but I do need this token. And I'm going to bring it, I'm going to nest it under the background on my canvas. And I don't have an image attached to it, so I'm going to do that right now. I'm just going to attach an image. And let's say that I want the starting position to be right at the origin at 0, 0. So it looks the same as my image. And yeah, it's just right there on the screen. Great. Nothing very special about that. And in the meantime, because it still has the same script attached to it, it's telling me that it's less than 5 or it's 5 or greater than 5 because of the logic that we've included in our script. That's pretty cool. So let's think of things that we might want to do when we have a board game or a card game or a different type of tabletop game. Well, certainly we'll want to have an object on the screen so that we'll be able to drag and drop. So like if I have a counter, whether that's a game counter or it's a card or some other type of counter, I'll want to be able to move it around the screen. And for better or worse, that's a super complicated thing to do in Unity, which we'll get to shortly within a few videos. But it takes a little bit of work in terms of understanding how the logic works for that to work, and we'll certainly get there. We just want to make a few things easier for us by understanding how we're going to get there first. Something else we might want to do is we want to be able to display and edit text that's on the screen. That's something that should be relatively easy to do once we understand all of the tools that are involved. We also may want to have logic like you're only able to drop a token in one place, but not anywhere on the screen. It has to go in like a drop zone, for example. We'll work through all of those different things in this video series. But first we need to understand how to create an object on the screen when we want that object to be there. So for example, if I want to deal cards or I want to place a token on the screen, those are important things that we need to use scripting for so that we don't just have like a bunch of items on the screen, like a bunch of cards on the screen that don't need to be there at the beginning of the game. And to do that, we're going to need a couple of things. The first thing is called a prefab. And in Unity, a prefab is a way of saying, this is a game object that I want to use over and over again, and I don't necessarily want to have it in my scene at the beginning of the game. The way that I create a prefab is just by dragging it from the hierarchy here up at the top of the screen to my project pane down here. Now you see that hopefully you can see that the game object has turned from gray or black to blue. That just means it's drawing from a prefab that lives down here in the project pane. Before I do anything else, I'm going to go into my assets directory, right click and say create folder, and create a folder called prefabs. Then where did we put that? That was in the scripts folder. I'm just going to drag it to the prefabs folder so that I can put all of my prefabs in the same folder. Now I have this token prefab that is pretty much exactly the same as this other token, but I can drag it from here back to the hierarchy. You see it says token 1 and token 2. So now I can just have now I have 3 different tokens. Whoops. that are in my scene. And so if I have a bunch of tokens that have similar functionality, I can just drag them or use them however I need to without having to create them over and over again here in the hierarchy. Importantly, now I can do crazy things like for token 1, I want it to be 150 in terms of width, whereas token 2, I want it to be 50 in width. And so these are all drawing from the original prefab, but they have some differences among them. And if I wanted to say, okay, now I've made some changes to these other ones, but I want even though I've made a change, let's say to token 2, this skinny one, I want that to be applied to all of my prefabs. I could go over here in the inspector and this little drop down that says overrides. If I click on it, I say, well, I've made no overrides. But if I have done other functionality that is let's say I've added a script to it or I've made some substantive changes to it, I could say, well, I want to override all of the changes that I made. I want to override the prefab that exists in the scene. Well, that exists in my project pane. We don't have to deal with that right now, but it's something to be aware of, that you can make changes to your tokens and then have them override the prefab in certain cases. Okay, I don't need these in my scene, so I'm just going to delete them from the hierarchy. Now let's take a look at our script and see something that we want to do. Well, right now I have some logic that we've established, and we've created a few functions, and we've created a conditional statement with our if and else if and else, and we've also created a for loop. One thing that I want to expose you to is that although it may be kind of boring just logging things to the console, this is actually super powerful for tabletop game development, because we're able to, for example, create a simple dice roller that nobody has to see. We can just create it ourselves here, and we can say I'll show you how to do some randomizers using our math to do randomizers. To say, like, if we wanted to have a simple dice roller and see what happens when we roll a d6, like a 6-sided die 100 times and see what the result is. We could do all of that just using Unity and logging it to our console and never have to touch the editor whatsoever. That's super useful for prototyping if you're trying to see what's the probability that someone will draw this card or roll this dice in this way, or any number of things. And that's something that you can play with to your heart's content. In Unity specifically, we're using our scripts to determine the functionality of our game. And the second thing that we're going to need to be able to handle some of that functionality is what's called a game manager. In my hierarchy, I'm going to just right-click here and create an empty game object, and I'm going to rename it Game Manager. And although we did it by adding in a component in the previous time we did this, I'm going to instead go to my scripts folder just to show you a different way of doing this. I'm going to right click and I'm going to say create C# script, and I'm going to name it Game Manager. And you'll notice that Unity gives it a different icon because it privileges Game Manager scripts in a different way than other types of scripts. That's not really important to us right now. And then I'm going to click onto my Game Manager, the object which is in my scene, and as you notice it's not parented to anything. It's just parented to the sample scene itself. It doesn't need to be in the canvas because we're not going to render it anywhere. And I'm going to drag this Game Manager script onto the Game Manager game object right here, so that it's now a component of that game object. And I'll double click on the Game Manager script, and it'll open an empty template script in my Visual Studio editor. And I'm going to make a little space at the top of my script. And I'm going to say public game object token. What I've done here is similar to the way that we declared variables in a couple of episodes ago, and we talked about different data types. Specifically, we talked about integers and strings. Well, for Unity, using C#, Unity treats GameObject as a type. And by saying public, we're saying in this script, I want to be able to access a GameObject that exists elsewhere in my scene. And that GameObject, I'm just giving it a name, like declaring a variable, and I'm calling it token. By doing that, now when I click on my Game Manager GameObject here, and I look at my script component, it now has an empty field next to something called token, and it says none GameObject. That just means that when I've created this public GameObject called token, it has exposed in the inspector an area for me to drop a GameObject into, like a prefab. So in fact, I'm going to delete this token from my hierarchy, and I'm going to find that prefab. Bring up the Game Manager again. I find my prefab token here in the project pane, and I'm going to drag it over to this empty field. And now I've made a connection between these two things with the Game Manager script and this token, and I've said I've declared a public GameObject called token, and I'm telling the script through Unity that this is the token I was talking about. These could actually have different names. I could have named this card and dragged the token over. That part doesn't matter as much. I've just said that this variable that I'm referring to, this GameObject, that lives here. That's this token here. And now I can perform operations on that token from within this Game Manager script. For example, in the start, let's take a look now. When I press play, because I've deleted it from my hierarchy, I won't be seeing this token in my scene anytime soon. There's nothing going on, just that background. But in my Game Manager script, in the start method, I can say GameObject lowercase token equals instantiate uppercase token, comma, new vector2 parentheses 0, 0, and parentheses, comma, quaternion dot identity, and semicolon after the parentheses. Wow, that is quite a mouthful. Let's just see what happens when we run this, and then we'll come back and explain every bit of it. Save my script, save my scene, press play, and it doesn't appear. We don't see it here in the middle of our screen. We don't see it here on the right-hand side of our screen. But we do see it here in the hierarchy, which is kind of crazy. We see this token clone, but it doesn't appear anywhere. And that doesn't seem to make sense because it's in my hierarchy. Well, that's because it's not parented to the canvas. If we bring it in front of the background, but still within the canvas, we see it here. It's kind of in the corner right here. If I change the position to 100 by 100, we see it. 0, 0. We see it right in the middle of the screen. So what are we doing here? What's the point of this whole thing? Well, the point is that what we're attempting to do is to create a new game object at runtime when the game starts running, rather than having it be in our scene from the get-go. And the way that we do this is by calling a function which is called Instantiate. So now's a good time to talk about instantiation and how you actually create game objects in your scene. We have this prefab called token, and that's an important thing because it establishes almost like a mold of what we want our game objects to look like. Right now it's just a little white square. But we want to create copies of it and so that we can use and manipulate them and maybe put them on our board and move them around. And we don't necessarily want to use this mold. We want to actually create other game objects that are copies of this mold. Doing that is called instantiating in Unity. And instantiate is a function within Unity that takes three parameters, or when you're if you were to write that function, it would be calling taking three different parameters, or in this case, because we're actually doing the work of instantiating, it's called arguments in C# speak. And these three arguments are, if I hover over instantiate with my mouse, we see that it gives me a preview of what it needs, what kind of arguments it wants me to pass into it. And it says object.instantiate, and the type is a game object. It says, what is the game object original? What is the original game object that it wants me to make a copy of or instantiate? What's the position? Right now it has a vector 3. We'll talk about that in a minute. And it also requires a quaternion rotation. So this is a long way of saying that when I want to create a new game object, a copy of it, I need to instantiate it, and I need to pass in three different arguments. The first argument is, what is the game object that we're making a copy of? As you can see, we're making a copy of the token, which is the prefab that we've exposed in the inspector. And then the second argument is, where's that thing going to go? Where do we want it to live? What is the position of it? And it's asking, originally we'll ask for a vector 3. Vector, we're not going to talk too much about vector math, but a vector 3 just means that what are the x, y, and z coordinates of this particular item or game object. We're actually just using a vector 2, and we're saying we want to set it at a new vector 2, a new xy coordinate of just 0 and 0. That's just our way of saying that we want to place this new game object at the origin. Finally, when you instantiate something, Unity asks you, what kind of rotation do you want on it? Let's say you're doing a 3D game or even a 2D game, and you wanted to set a rotation when the object is instantiated. Right now, by saying quaternion.identity, it just means that we don't want it to have any rotation. That's all we really need to know about that right now. So that explains what is on the right side of the equal sign here. But why are we saying game object token? We've already said game object token up here. Essentially, we're saying we have a public game object, which is a uppercase token, which we exposed in the inspector, and we dragged our token over to it. In our start method, meaning when the game manager is created in our scene, we have to declare a private game object, which is also called token. That's similar to saying remember how we said in our other script, we set, where did we do this? Oh, we didn't actually do this in this part of the script. We did it in an earlier video. We can do it again here. Remember how we said int I equals 0 or string hello equals hello world, and hopefully you did your homework and looked up static versus dynamic typing. Essentially, when we were saying int I and we were saying string hello, we're declaring what is the or initializing. We're declaring what is the data type that this variable should be attached to. And we're doing the same thing with game object token. We're saying that this variable token, its type is game object. It's a game object, and I want you, Unity, or the compiler to know that when I'm writing my code. And I'm saying this little lowercase token is a private game object. It's only accessible here within this script rather than elsewhere in my scene. And I'm making that equal to the instantiation of a new game object that is a copy of this token game object that I've referred to, its position should be at the origin, a new vector 2, 0, 0, and it should have no rotation. Its rotation is represented by quaternion identity, just a way of saying no rotation. Great. So that hopefully explains what's going on with that. So now when I hit play, it exists in the scene. It's not being shown on my screen because it's not parented correctly. We'll deal with that in a moment. But we'll see in our console that it is still telling us that it's less than 5 or it's 5 or it's greater than 5, because not only is the game manager having stuff happen right as it's created in the scene, but all of this logic is still being called when we create this game object for the first time, the token. So what we're going to do here, we're going to delete a bunch of this stuff. And we're just going to, let's delete everything, actually. How crazy is that? We're going to delete everything in between the curly braces of our debug script. And instead, we're going to create a new function. And we're going to call it void log to debug. And well, we need our parentheses too. And we're actually going to make it a public void log to debug. In between the curly braces, we're going to say debug log hello world, and put a semicolon after that. In our game manager, we're going to say token dot get component debug script within these arrows, parentheses, dot log to debug. Let's see what this does first, and then we'll talk about why we're doing it. We're going to hit play, and we see that the token is instantiated into our scene correctly. And now in the console, we see hello world, which is kind of funny because we're not actually calling this function from within the debug script, which we were doing before. Originally, we had the start method and the update method, which happens when the game object is created for the first time and on every frame, respectively. Now we just have a public function called log to debug that logs to the debug hello world. And instead of calling it from within the debug script, we're calling it from another script. We're calling it from the game manager. And what we've done here is we've already said, okay, create a new game object called token, a private one, instantiate it, and copy this this other prefab up here. And now we're saying token.getComponent. We want to get a component that's attached to this token, not necessarily the prefab because it will have created a game object for it, but we want to get a component that's attached to the prefab, and that component is called debug script. And so we put in these arrows, in between these arrows, debug script. Get the debug script component, and we just put this these parentheses, close parentheses next to that part of the script because the get component is a function or a method itself. And then we say dot log to debug. So we've got that component, and now we want to get the log to debug function from within this component that we have gotten. And so after we've created this new token, we want to get the debug script component and use the public function debug, which is log to debug. If I deleted this and made it either just left it without this public declaration, or I said private void, that means that it's only available within the scope of this C# class. It's not available here in the game manager script. And so when I mouse over this log to debug, it says it is inaccessible due to its protection level. It's not accessible outside of its scope. And that's why I have to say here public void. You might be asking yourself, well, now it works. You might be asking yourself, well, why would I want to have a public versus a private function? Why not just make them public all the time? Sometimes there's information that you want to hide from other places, like let's say I'm using bank account information or credit card information. I may not want that to be accessible or visible elsewhere. That's called, it's what's used in what's called, if you've heard of a closure or encapsulation. We can talk about that at another time. Or you can look at it for your homework, even better. Or it might be that I have similar naming conventions in different scripts, and I don't want to get confused with a log to debug function in this script versus in another script, so I might make them private. Generally, it's just one of the ways to keep clean code and have things compartmentalized when necessary. Otherwise, if I need to access them in other areas of my scripts, I will make them, or my scene, I will make them public. As a rule of thumb, you want to keep things private unless they need to be public, just to keep things clean and organized and compartmentalized. And that will also help you with your debugging, so you can find out where things went wrong more easily. So let's apply a little bit of the knowledge that we have developed to do two things. We want to display multiple things to our screen, and also we want to be able to parent them through code into our under our canvas. So for example, when I press play, I automatically have this token appear in my screen, but I don't see it anywhere. I have to drag it from my in my hierarchy so that it is underneath the background and parented to the canvas, and then it's like, you know, at this weird place, probably because of the way that we've instantiated it. So how do I address that? Well, there's a few things that I can do. First, when I say token get component, that's actually going to give me a clue as to what I need to do here. Well, notice that when I click on this token, I see that one of the components is the debug script. But another one is this rect transform, and the transform, as you remember, has to do with the location and the width and the height of the game object. So I'm going to say here token dot get component transform. That's getting this component, which is the transform. And I have to remember to put these two parentheses right next to it because get component is a method itself. Dot parent, set parent, and then we'll just leave that blank for now. And what we're saying is that we want to set the parent of the transform to something else. But we don't have that something else just yet. We want to set it to the canvas. So we need to declare a public game object canvas. Now we could do multiple things. One of them is, for example, to drag the canvas to our script like we did before. But we're going to try a different way just to learn something. We're going to say, in our start method, above everything else, we're going to say canvas, which we've already declared up here, canvas equals gameObject.find, and in parentheses, we're going to say canvas in between quotation marks. That just means that when the game starts and this game manager is created, I want to find something in my hierarchy that's called canvas. In fact, let's change the name of this to be called main canvas with a space in between main and canvas. And I'll change this so that we see that when I say GameObject.find main canvas, I'm asking Unity to look for a game object in my hierarchy that literally has the name main canvas with a space in between it. That's an important concept for us to learn for use later. It's similar to the way that we instantiated or we located the token, but it's a little bit more useful if I don't know where that token is going to be at runtime. I can't just drag a prefab over like I did before. We'll encounter that in a later video tutorial. And now at the bottom of my this start method, I'm going to say token.getComponent, find the transform, and then .setParent. And if I hover over it, it'll say set the parent of the transform, and I have to determine what transform I want it to use, and I'll say set parent canvas dot transform. And right now I'm just going to say false, and I'll explain why in just a moment. Save this and hit play. And now we'll see that it is parented correctly. Not only do we see that here in the hierarchy, it's parented to the main canvas, but it's also parented on screen. So what's happening here? We create the token by instantiating it. And then we say token, get the component, get the debug script, log to the debug, which we'll see actually that happened here down here, hello world, or here in the console. And then we say get the transform and set its parent to the canvas's transform, which is equal to the main canvas that we found at the beginning of our start method. And this actually takes two arguments, this set parent function. And if we hover over it, it says it gives us a little tooltip that says void transform.setParent, and it requires a parent transform and a Boolean called world position stays. We haven't talked about Booleans yet, and now is a good time to discuss both world position and Booleans. A Boolean is a data type that is essentially a yes or no. It has two different potential possibilities. If I say bool true or false equals true, I won't see any issues. If I say it's false, I won't see any issues either. But if I say bool true or false equals 0, I will get a notification for Unity that it cannot implicitly convert type int to bool. That shows me that Boolean is a data type that we can use in C# programming and also in Unity if there are conditions that need to be met whether or not something is true or it's false. So like we could think of a Boolean as game has started. If the game has started, then it's switched to true, and we might have some logic in our game. We probably will have some logic in our game that is determined by whether or not the game has started. We could say, is player 1 alive? That could be a Boolean, and if player 1 is alive, we might have some logic, or if player 1 has been destroyed, or that their token has been destroyed, that might have other logic or consequences based on that. We'll be using that quite a bit in our programming, and it's used here. You see that it's false as the second argument because Unity wants to know whether or not when we parent this transform, should it keep its world position, like where it is in the world, or should it have a new world position based on the parent transform that it's being parented to. Here we've said false. Don't keep its world position. Parent it to the canvas and have its position be determined by that new relationship. To make a long story short, we're not really dealing with it here, but I want you to know everything that we're encountering in our code rather than just seeing it as magic. Even if we don't understand fully its implications now, we definitely will get to it later. And I want you to be exposed early on so that perhaps you'll have an aha moment, as I have had in working with these different parts of Unity, so that they make sense when you're getting to them, rather than just taking them for granted and saying, okay, we'll just write this script and it'll work. It's better for you to encounter things that we might not understand from the get-go, but we will continue to encounter over and over. And it is the process of repetition and working with these things for yourself that actually help with the learning. Great. So we can delete this Boolean. And we'll save it, and we'll just run this again so that we see that it's having expected behavior, that it appears in the middle of my screen, it's been parented to the main canvas, and it's still logging to the console. Hello world. So let's say instead of 1 token, I want to actually display 5 tokens. Well, that's easy to do. Here in my start method, I can write a for loop, and I can say for integer I equals 0, semicolon, I is less than 5, semicolon, I plus plus. Remember from one of our previous videos, we said that that just means we're starting an integer I, or a variable name I, at 0. I should be less than 5 for us to keep looping, and we're going to increment I essentially until it reaches 5, so we don't have a infinity loop. Curly braces, and then we're going to Control X or cut all of this stuff and put it within that for loop. Now, when we hit save and we hit play, well, we only see one thing on our screen, but we do see in the hierarchy here, we see these 5 tokens. And we also see hello world being displayed 5 times in our console. That just means that there are 5 of these things, but if we look at our, if we grab one of them and we change the position of X to, let's say 50, maybe something longer than that, 150, they exist in our scene, but they're just rendering on top of each other. We could just, move these around manually, but it'd be interesting to do it programmatically. That's relatively easy to do. We can go into this for loop, and we can say, based on I, which is going to be 1, 2, 3, 4, or 5 every time it loops through it loops over this code, we can say instead of instantiating it at a new vector 2 of 0 and 0 every time at the origin, we can write some logic here, and this will be the x coordinate versus the y coordinate. We can write some logic here based on I. We can say instead of at 0, we could say the x coordinate should be at I times 50. Let's see what happens when we do that. Hit play, and it just has kind of like lumped them together in this one long line. So maybe we need another 100 attached to that. I times 150. Great. That's pretty cool. We've put it right here, separated with a little bit of width so that we can see each of them. And what's happening here is that as this loops over the each of the lines of this code, I starts out at 0, and so 0 times 150 means that the x coordinate for the first token should just be at 0, 0, but the next one should be at 1 times 150. the one after that should be at 2 times 150, and then 3 times 150, so on and so forth. So we're just using I, which is incremented each time. In fact, we can just say debug.log I. And when we press play, we see that I is equal to 0, and we get a hello world from this first token. Then I is equal to 1 times 150 would put it 150 pixels or Unity units to the right. And then we get hello world and 2 and so on and so forth until we've got 5 hello worlds. And we never see I being equal to 5 because we've said that we want I to start at 0, and we want our loop to end if we want our loop to keep going if I is less than 5. So if we say 0, 1, 2, 3, 4, that's 5 different times that we run through the loop. So I will always be less than 5, and each time we increment I, we also instantiate a new game object, and that's pretty cool. That's how we're able to display things on screen programmatically. Let's take that just a step further and tie together a few different things that we've learned over the course of the past few videos. Let's start by creating a private Boolean called isTrue. And we'll say that it's true. In our start method, let's say if is true, do some logic. And what do we see here? We have missed our parentheses. If is true, do things. This is another way of saying is true. If is true equals true, as we've seen in our previous video about conditional logic. This is just shorthand. If you say if is true, that just means that if is true, do logic. So let's wrap all of this stuff here in this part of the code. So we're saying if is true, run this loop. And is true should be true because it starts out as true. And so that works. Let me go back to my script. And right at the top of this script, this start method, this code block, I'm going to say is true. Is true equals false. I'm changing it to false. When I hit play, I don't see anything on the screen anymore because my conditional logic has said if is true, do all this stuff for me. If it's not, don't do anything. Well, is true started out as true, but then we changed it to false. Let's see what happens if we change is true to false in our if statement. If is true equals false, run it again. These things render on screen again, which is great. So it starts out as true, we make it false, and we're saying if it's false, run all this code. Just like we did shorthand before by saying if is true, you can just put an exclamation point in front of this, and that is shorthand for saying if it's not true, if this expression is not true. So in this case, we're saying if is true is false, run our code, and I save it and press play. That's just shorthand that allows us to run the same thing we did before. We're saying if is true is false, go ahead and run this code, and it's doing it for us. Okay, let's make that a little bit easier on ourselves and just delete this line up here. And delete the exclamation point. So we're just saying we've declared a private Boolean called isTrue, and we're saying that it's true at the top of our script. And now in the start method, if we're saying if isTrue is true, go ahead and do this stuff, and it does. Let's add one layer to this and say that, let's say we have a lot of stuff in our start function and we don't want necessarily for that to be the case. Well, let's create a new function here, and let's call it a private void create tokens, parentheses, curly braces. And let's pull all of this stuff, Control X or cut it, paste it here in the middle of create tokens in this code block. And then in our start function, we'll just say create tokens. Hit play. And we see the same functionality. What we've done, we've abstracted a little bit. We've taken all of this create tokens functionality. We've created a new function, sometimes called a method, and we've placed all of it within the curly braces, and then we call that function from the start function that happens at the beginning of the game when the game manager is created for the first time. If we wanted to do some other funky things, like let's say we wanted to determine how many tokens should be created at runtime rather than, or by some variable or some design philosophy, or even by how many the player wants us to create, we could do that, for example, by saying creating a parameter within create tokens, saying let's call it int number of tokens, and I'm using camel case here to signify that it's with a lowercase to say that it's just a private variable. And so create tokens, let's just say create a number. We'll say 5 because we've been using 5. I'm passing in 5 as an argument here to this create tokens function, and just a reminder that when we are declaring the function, we call whatever goes between the parentheses a parameter, and then when we're calling the function, whatever goes in between the parentheses is called an argument. That's just terms that you'll need to know in computer programming. And then here during my for loop, rather than just saying 5, we can say I is less than number of tokens. Now when I hit play, save it and I hit play, I see the same functionality here. I see 5 different tokens being displayed on screen and parented correctly, and they're all saying hello world. I can probably delete the part where I'm debugging, I'm logging to the console what I is. Let me just do that so we don't have to look at it anymore. And all we're doing here is that we're saying instead of I being less than 5, we're saying we should keep looping over this code block until I is less than whatever this number of tokens number is that is set elsewhere, like the dependency injection that we talked about in a previous video. Rather than it is just being a static number, well, maybe we want to create 6 tokens. And so we pass in 6 as an argument to this create tokens function in our start function. And now when we get to when it's called, we pass in this number 6, and so I should now be less than 6 rather than less than 5. Let's see if that works. We hit play, and yeah, that's happening just great. We have 6 tokens instead of 5. We could do 7, we could do 10, we could call this create tokens multiple times, and perhaps, let's say, instead of this being starting at 0, we might want to, the y coordinate, we want it to actually be dependent on I as well. We could say I times 150 as well within parentheses as the I coordinate, and we'll see that when we hit play this time, Well, one of them's going off screen, but we're changing the value of the y coordinate programmatically, so things are rendering on screen based on what we're asking to do in our for loop, which is pretty awesome. That's something that we'll use over and over again in our scripts. And although there's not much functionality right now, like we're just rendering things onto the screen, it's a really, really useful step in our journey of creating a card or a board game or other type of tabletop game to be able to render these things on screen. The thing that we're missing is a little bit of interactivity or interactive functionality, which is what we'll look at in our next video, now that we're able to render things on screen from within our scripts. So if you've gotten this far, you've done a great job. I would say do a little homework by looking up some of the terms that we've talked about, like arguments, parameters, and instantiation and other things that we've covered, as well as try and make this game your own a little bit. You might not know how to do everything, but maybe change the colors of the tokens that you're rendering, or the size, or where they render on screen. Try and make something that looks a little bit akin to something that you'd like to work on. And definitely become comfortable with logging things to the console and see what you can create. I hope this video has been helpful for you. If it has, please like it and subscribe to my channel. I'd love for you to check out my books and games at entromancy.com or nightpathpub.com/entromancy. And please tell someone about my books and games. I'd love for more people to know about entromancy and about tabletop gaming and my novels in general. And we'll see you next time.